NASA has finally released a new batch of long-awaited images, and the agency's tone has shifted from cautious to downright startled. And man, things just got even stranger. We are talking about non-gravitational acceleration that refuses to behave, surface reflections that defy the rules of interstellar debris, and a rotational pattern that no natural visitor should ever display. Let's get straight to what matters. On 29 October 2025, when the 3I Atlas object reached its predicted deceleration window near the outer heliospheric boundary, the Solar and Heliospheric Observatory captured something disturbing. A brightening event, small, sharp, and unnervingly geometric, flickered across the northern limb of the object for less than 1 second. That should have been impossible. NASA held internal briefings for 2 weeks before acknowledging the anomaly, and when the new images were finally made public, their silence spoke louder than the data. Every frame raised more questions. Why is the object still holding a near-constant spin period? Why does its brightness curve remain jagged when it should be smooth? And why do the newest images show edges where there should be no edges? And here we reach the moment of truth, folks. The 3I Atlas object, detected in mid-2020, was initially classified by the National Aeronautics and Space Administration as a standard interstellar debris fragment, possibly a shard from a long-dead exoplanetary collision. But even in those early days, astronomers at the European Space Agency noticed something unusual. Its light curve showed repeating spikes, not random, not chaotic, repeating. The early trajectory modeling suggested that the object's path was influenced by subtle but measurable non-gravitational forces. That alone was surprising. Small cometary bodies can release jets of gas that push them slightly off course, but this object showed no outgassing whatsoever. No coma, no tail, no sublimation signature, nothing. It was as if an invisible hand kept nudging it. And that's when everything changed. By late 2024, the Atacama Large Millimeter Array observed a persistent thermal plateau. The object held a stable temperature despite entering colder space. A natural body should have cooled. This one refused. NASA scientists tried to explain it as a combination of surface albedo and rotation, but privately, several teams admitted confusion. In early 2025, the James Webb Space Telescope recorded something even stranger. As the object rotated, a specular reflection, a highly concentrated glint, flashed across its limb, not diffuse reflection, not dust scattering. A glint consistent with a flat or slightly convex surface. But here's the crucial point. The newest images released this week do not match the predictions. The brightness should have declined as the object moved farther from solar illumination. Instead, the curve sharpened. This implies surface geometry, not tumble. And according to NASA's statement, the rotational wobble remains less than 0.1 degrees. Astonishingly stable for a natural fragment traveling at tens of kilometers per second. And that, my friends, changes everything. First anomaly, the impossible trajectory. Probability 0.2%. When NASA recalculated the expected path of the 3I Atlas object after the new images came in, the numbers simply did not add up. A natural interstellar object should lose velocity as it drifts away from solar influence. Instead, the deceleration curve remained nearly flat. The trajectory held its precision like an aircraft maintaining altitude. According to the Jet Propulsion Laboratory, the probability that a natural body would produce this exact path is less than 0.2%. To visualize what that means, imagine throwing a pebble from a mountain and having it glide perfectly straight for several kilometers without wobbling. Nature does not produce that kind of stability. Yet here we are. Astronomers compared the data to the path of the first known interstellar visitor, Oumuamua. But even Oumuamua showed chaotic tumbling. The 3I Atlas object does not. It moves like a crafted object with internal mass distribution optimized for stability. And the real kicker? The new images show faint diffraction halos on its leading edge. Diffraction requires structure. And where there is structure, there is design. It is not proof, but it is not nothing. Second anomaly, the non-gravitational push, probability 0.1%. According to NASA, the object continues to experience a tiny but consistent acceleration toward the solar north. No jets, no outgassing, no known mechanism, just a steady push. The math says the acceleration is equivalent to a pressure force spread across a broad, flat plane, almost like a light sail. But its brightness does not match that theory. The surface is too dark for efficient propulsion. Avi Loeb from Harvard University noted that the signal-to-noise pattern resembles controlled torque rather than random motion. Controlled, not random? Imagine you are watching a leaf drifting, but instead of spinning chaotically, it adjusts its tilt as if correcting itself. That is what the new images imply, a pattern that is responsive, and NASA has no natural explanation. Third anomaly, the geometric flash, probability 0.3%. The Solar and Heliospheric Observatory captured a brief, sharp glint exactly 1 frame wide. For that to happen, the object must have rotated a perfectly flat section into direct alignment with sunlight. Natural rocks do not polish themselves into mirrors, not in interstellar space. The glint lasted less than a second, but it was enough to spike spectrometers. ESA scientists call it a non-stochastic reflective event, meaning it was structured, not random. In everyday terms, it looked like a solar panel catching light. This is where things get uncomfortable. If the surface is artificial, then it has a function. And if it has a function, then someone or something engineered it. Fourth anomaly, the thermal plateau, probability 0.5%. Thermal readings show the object maintaining a stable temperature across its surface, even as it enters colder space. Infrared measurements from James Webb indicate a repeatable heat map with almost no variance. Natural bodies always show thermal variation. Day side and night side are never equal. To understand how weird this is, imagine leaving a metal plate in the snow, but finding it stays warm. It does not make sense. A thermal plateau requires either insulation or internal heat. Neither is seen in comets or asteroids of any size. This is the anomaly NASA is most uneasy discussing. A stable temperature in deep space implies energy management, which implies engineering. Fifth anomaly, the rotational consistency, probability 0.15%. The object's rotation remains locked at just under 8 hours, year after year. No drift, no wobble, no decay. Natural bodies spin irregularly as they lose mass or encounter micro-impacts. This one behaves like a gyroscope. According to the European Space Agency's internal notes, a stable rotation in a chaotic gravitational environment is unprecedented. The only known objects that maintain consistent rotation without correction are spacecraft. It raises an unsettling question. Is the 3I Atlas object still actively stabilizing itself? Sixth anomaly, the surface ridges, probability 0.4%. The newest images show faint, linear ridges across the surface. Straight lines, parallel, evenly spaced. Natural erosion does not produce repeating geometry, and the ridges run counter to expected fractal patterns seen in ice fragmentation. NASA scientists compare them to struts or internal framework outlines, the kind used in lightweight aerospace hulls. These patterns appear again and again across multiple wavelengths. The lines are not dust. They are not artifacts. They are something physical. Seventh anomaly, the polarization signature, probability 0.3%. When light reflects off the object, the polarization is too uniform. Comets scatter light in chaotic ways. Asteroids scatter irregularly. The 3I Atlas object reflects with tight coherence, like carbon composites or metallic foils. The Atacama Array detected a polarization curve consistent with engineered materials. Thin, layered, and anisotropic, meaning directionally organized. You do not get anisotropy without manufacturing. Eighth anomaly, the shadow dip, probability 0.2%. In the most recent imaging sequence, a tiny shadow dips across the object's rear, a dip that moves independently of rotation. That means something shifted, extended, or folded. A moving structure implies mechanical motion, not natural flexing, not thermal cracking, mechanical. Imagine seeing a bird far away and noticing its wing flick for just a moment. You know it is alive because the motion defies randomness. That is what this shadow means. Ninth anomaly, the fragment that never detached, probability 0.4%. Early in 2023, astronomers saw a small protrusion on the object's southern edge. Many predicted it would break off, as ice fragments often do. It never did. Instead, it changed shape slightly. According to NASA's statement, shape evolution is inconsistent with natural erosion models. It is consistent, however, with adaptive or articulating structures. A fragment that shifts without detaching suggests active structural integrity. 10th anomaly, the acoustic echo, probability 0.2%. Using deep space radar pings, NASA recorded an unexpected echo signature. The signal returned faster than expected, meaning the surface was smoother and flatter than modeled. Not porous, not rocky, something closer to a smooth hull, and then came the real shock. The echo doubled. A secondary return, the kind produced by layered interiors, a hollow body in interstellar space that stretches the limits of natural formation. According to the National Aeronautics and Space Administration, none of the anomalies individually prove artificiality, but together, they form what one NASA analyst privately called the most non-natural natural object ever recorded. Harvard astrophysicist Avi Loeb suggests the object fits within the broader category of interstellar technological debris. Loeb is not claiming it is alien in the pop culture sense. He is being scientifically rigorous, but he emphasizes the pattern: repeating geometry, non-gravitational acceleration, stable rotation, thermal anomalies. These are not random coincidences. Researchers from the European Southern Observatory emphasize caution. They argue that unknown natural processes could still be at play, but even they admit the newest images complicate that interpretation. The James Webb team notes that the specular reflection is difficult to dismiss. It would require a flat, mirror-like surface nearly 50 meters wide to produce that glint at such distance. No known natural process forms 50-meter glass smooth planes. But here's the crucial point. Every time NASA updates the model, the object resists explanation. It refuses to behave like a comet, asteroid, or shard. It behaves like something with mass distribution, thermal regulation, and surface geometry optimized for endurance. And that, my friends, that changes everything. If the 3I Atlas object is artificial, even partially, the implications are staggering. It would mean humanity is looking at its first confirmed artifact from another star system, a relic that drifted through interstellar darkness for millions of years before entering our solar neighborhood. It would be a mirror, held to our understanding of the cosmos, just as Galileo shattered the idea of a perfect sky and Einstein redefined space and time. The 3I Atlas object challenges our assumptions about technological evolution beyond Earth. If engineered, its purpose could range from probe to debris to something we cannot yet imagine. The universe may not just be teeming with planets, it may be echoing with the remnants of civilizations older than our species. And that thought is both humbling and electrifying. So, what do you all think about this story? Natural phenomenon, alien technology, or something entirely new? Leave your theories in the comments, and if you want to follow every update in this saga, subscribe to the channel, because the next observation window in late December promises to be epic. New data from Webb, SOHO, and the Atacama Array are already scheduled, and you know we will break it all down the moment it arrives. See you next time.